Right, let's do a discussion on exercise number 5. So we will be discussing number 5, 9, 12, and 13 based on the poll. Okay, so question 15. Let me find the question. Sorry. Okay, so a parcel is launched at an initial speed of 3 meters per second up a rough plane inclined at an angle of 35 degrees above the horizontal. And then it gave us the coefficient of kinetic friction, which is 0.3. Now we have to determine the maximum distance traveled by the parcel up the plane as well as the speed of the parcel when it slides back to the starting point. Okay, so firstly let us draw the situation lah. Okay, just gonna use orange. So it is basically a inclined plane lah. Okay, so inclined plane. Okay, plus 2 it is was it 35 degree? I think, yeah, it is 35 degree above the horizontal, so this is 35 degree. Okay, so there's a block, the block lah, somewhere around here pun boleh lah. Okay, so the block is moving somewhere, moving up the inclined plane. Okay, dia ada tuliskan, dia cakap dia move up the inclined plane. Yes, up the rough plane lah. So this is the velocity as well as the displacement lah. Okay, alright, so given in the question is the initial speed, which is 3 meters per second, and then dia punya coefficient of kinetic friction, which is 0.30. Okay, right, so the first one we have to find the maximum distance traveled by the parcel. Okay, so we have to find the value of distance. Okay, so firstly let us draw the free body diagram. Okay, so this is the inclined plane, right? So now let's draw the forces experienced by the block. So obviously there's weight, and then this is a rough plane, so ada friction force, lepas tu ada normal force. Okay, so that is basically the forces being experienced by the block. So the angle is here, this is 35 degree, this is mg, this is the friction, this is the normal force. Okay, so why does the friction is here, pointing here? Because this is moving up, so friction is opposing the motion, so mesti opposite direction. Okay, alright, so now we are gonna solve this by using work kinetic energy theorem. Okay, unless it mentioned in the question, you have to use work kinetic energy theorem. You have to only use this lah. Tapi if dia tidak mention like this question here, you can actually also use chapter 4 punya solution lah. Okay, so but this is chapter 5 punya exercise, so I'm gonna use work kinetic energy theorem lah. Okay, right, so we know that work is equal to work kinetic energy theorem is equal to the change in kinetic energy. Okay, however we have to find not however, okay, never mind. So work is equal to the net force times dengan the displacement, and then times dengan the cos theta. Okay, the angle between the forces dengan the displacement equal to change in kinetic energy. Okay, so what I will do is I will consider all these forces lah, the work for all these forces, untuk friction, untuk the weight, dengan the normal force. Tapi sepatutnya normal force ni equal to 0 lah, work dia y, sebab this is 90 degree to the displacement there, to the distance, which is s here. Okay, so let's just do this. So first it is for friction, so Fk as cos 180 degree. Okay, kenapa 180 degree? Because our displacement is going up the plane while the friction is going against the motion, so this is 180 degree. Okay, right, lepas tu we gonna look at mg. So mg as cos berapa? Dari s di sini start 180 degree plus dengan 90, yang angle di sini nih 90 minus 35 degree. Okay, so if you add those, you'll get 235 degree equal to half mv square minus half mu square. Okay, right, now sekarang ni dia suruh kita cari maximum distance traveled. Okay, maximum distance traveled meaning the final velocity when it reached that maximum distance should equal to 0. Okay, so that's why the final velocity here would equal to 0. Okay, lepas tu now we can continue solving this problem. So we know that F friction is equal to mu kn, so s cos 180 degree plus mg s cos 235 degree equal to minus half mu square. Okay, so now we have to find the value of n. So how do we find that? We are going to use the y component, which is Fy equal to 0. So n minus mg cos 35 degree equal to 0. So n here is equal to mg cos 35 degree. So now you can substitute this value into here. Okay, so you'll then get mu k mg cos 35 degree s cos 180 degree plus mgs cos 235 degree equal to negative half mu square. Okay, so if we see, we can actually cancel out the value of m because each of this has the value of m, so cancel saja lah. Okay, what else? So after you rearrange this, you can actually get the value of s. So it is mu k g cos 35 degree, cos 180 degree plus g cos 235 degree negative half u square. Okay, so the value of s that you will get is 0.56 meter. So that is the maximum distance traveled by this block. Okay, boleh, so don't get confused on how to rearrange this, but because sometimes I get question about how do I rearrange this. Just make sure you rearrange it without making any careless mistakes lah. Okay, so the distance traveled, the maximum distance traveled by the block up the inclined plane is 0.56 meter. Okay, alright, lepas tu we look at question B, which is asking about the speed of the parcel when it slides back to the starting point. Okay, so now sekarang ni dia punya free body diagram. Let me use this, copy, paste. So now the free body diagram, I mean the motion, is against, is going down. It is sliding back down. So it is, instead of going up the plane, it is going down the plane. Okay, so the free body diagram changed lah. Okay, so the value of Fk is now, I mean not the value, the direction of Fk is now in the opposite direction lah. Okay, so Fk is now here. The rest is still the same. Okay, so we then gonna use the apa? Chapter 4 punya solution, which is total force at x is equal to ma. Okay, so now the direction of acceleration is going down, which is a here. Okay, so now Fk is negative because it is against the motion of the acceleration, plus dengan mg sine 35 degree equal to ma. Okay, so this is, I'm gonna rearrange supaya mg ni yang positif di depan, minus mu k n equal to ma. Wait, I don't want to use black. Let me change this to red. Okay, so now we have to find the value of n. We actually know what is n, which is n minus mg cos 35 degree equal to 0. So n is just mg cos 35 degree. So just substitute lah the values, sine 35 degree minus mu k mg cos 35 degree equal to ma. Again, we can cancel this value of m just to simplify our calculation. You then get acceleration is just g sine 35 degree minus mu k g cos 35 degree. You should get the acceleration to be equal to 3.22 meter per second square. Then we have to find the speed by using v square u square plus 2as. Okay, so v square is what we are looking for. At the top, before it starts sliding down, it will have a 0 speed before it starts sliding down, kan? Okay, so v equal to u0 plus 2, 3.22.56. So the speed of the block as it starts sliding down should be equal to 1.9 meter per second. Right? So that is how you solve question number 5. If you have problem using the work kinetic energy theorem, you can opt to use this type of solution. I mean by using chapter 4 punya solution lah. Okay? Alright, so that is the solution for exercise number 5. Exercise number 5.